Hi, hello everyone. This is the video dealing with section 24, the quadratic formula, and this is the second part where we focus on the applications. Now, in this video, we're going to cover the applications that we are likely to see in our course. There may be other types of applications, but in our course, these are the only three that I'm going to cover that you might be able to see or you might be able to expect on an exam or final, for example. Now, recall that the quadratic formula looks like this: ax squared plus bx plus c, where a is not zero, because if it is, then we just have a line. So here's the quadratic formula as we've seen it before: minus b plus or minus square root of b squared minus 4ac over 2a. So we're going to need this to solve these problems. It is possible that in one application, especially the one that you're seeing here on the screen, the quadratic formula may not be necessary, but we're going to use the quadratic formula to solve it. And in the other applications, it might be that the problem is not factorable and we'll use it. But in any event, I'll try to use the quadratic formula in all three cases here for you to see. So the two types of applications might be one, it's more of a mathematical problem. And the second is one that may involve, more geometric figures. In either case, we're going to have a verbal problem that needs to be converted to a mathematical problem and then solved. Okay? All right, so let's take a look at the first type of problem. So these are the more mathematical problems. So in this case, I have a statement that 2 times the square of a positive number plus 3 times the number is equal to 65. What is that number? So we have to, this is a verbal problem, we have to translate this problem introducing a variable. We don't know what the number is, so we're going to call it x. Try to create an equation from this and then solve it mathematically. So 2 times the square of a positive number. So 2 times the square of a positive number x. So 2 times x squared plus 3 times the number, 3x, is equal to 65. So the word is the equal sign. So here's the equation. Now we can, from here, we can see that this is a quadratic equation, which then we know to set it equal to 0 in order to solve for x. So I'm going to have to subtract 65 from both sides. And now, if this is, any problem, we could try to see if it's factorable. I think it is factorable, but we can also use the quadratic formula because this is a section where we have to, use the quadratic formula. Notice that the problem didn't say for you to, you must use the quadratic formula, but because we're practicing it, we're going to try to use it. So here's the formula again. And again, in order to use these coefficients, the quadratic equation has to be written in this form. So let's put the coefficients A, B, and C into the formula. So minus B plus or minus B squared minus 4 times A times C. 2 times A. So minus 3 plus or minus, obviously the denominator is easy, it's 4. And now I have to separately calculate the value inside of the radicand. So 3 squared is 9 minus, so I have 8, negative 8 times negative 65, so it's going to be a positive number. And obviously you can use a calculator here. So 8 times 65 520. And obviously this is 529 inside of the radical. Now, very likely this is something that we can take the square root of. So let's see. 23. So this is 23. So -3 plus or minus 23. Let me just write this a little bit cleaner here. There you go. Now, the fact that the radical came out to be a perfect square indicates that this equation was factorable. But that's okay. We're just practicing to use the quadratic form. So the two equations or the two solutions are -3 plus 23 over 4 and -3 minus 23 over 4. Okay. So in the first case, 23 minus 3, 20 over 4. And in the second case, -26 over 4. And in this case, 26 cannot be divided by 4, so we just reduce it by 2. Okay, so here are the two answers. Now, um, the problem began if you saw it before, right? It's likely that the person who wrote this problem, which was me, but in an exam you don't know, intended for the answer to be a positive number. So in that case, you would show me the answer negative 13 over 2, but then only keep the positive. If the question said the square of a negative number, then you would keep the negative, but get rid of the positive. Okay? So this is the first application, a more mathematical type of a problem where no, geometric, pictures or figures are involved. Now, the second kind and the last one are more geometric. So for example, this is in your textbook, your workbook, where involves a geometric, figure. So a rectangular garden, so it helps, that you maybe immediately write the shape. So here's your rectangular garden, whose length is, so here's the length, here's the width. So the length is equals 5 yards longer, 5 plus twice the width, right? So the length is 5 yards longer plus twice the width. And then they say that the area is 71. So the area, so we know what area is. Area is length times width is 71. So now we have two equations. I guess we didn't need the picture, but here it is anyway. So we have the first one, length equals 5 plus 2w, and we have that length times width is 71. So we needed to know that area for the rectangle is length times width. Now all I have to do is solve this equation. But notice that, and in this type of application, this always happens. I have one variable being defined in terms of the other. All I have to do is get this variable and replace it into the other equation. So using second equation, I am going to replace L with 5 plus 2W. times W equals 71. And now I'm going to solve this. So I'm going to distribute W. All right, so this is 5W plus 2W squared equals 71. And I can see it looks like a quadratic. I'm going to rearrange it. I'm going to write 2W squared plus 5W, and I'm going to subtract 71 from both sides. So this is the equation I need to solve. And I'm going to solve using the quadratic formula the same way as I did before. Now, this is W equals minus B plus or minus B squared minus 4AC, everything over 2A. Now, notice again, it's everything, not just the radicand. All right, so let's see. W equals, so this is your A, B, and C. Now, because this is an application where you may have an area, all right, it's possible that the radical will not be a perfect square. If that's the case, you're not going to simplify the radical, you're going to use the calculator to get a decimal approximation. So minus 5 plus or minus, and you'll see in this case, I'm hoping that the radical is not going to be a perfect square. Plus or minus b squared, so 5 squared, 4 times a times c negative 71. Everything times 2a, 2 times 2. All right, so let's see. So minus 5 plus or minus 4, right? 2 times 2. Now, the radical, let's evaluate it, and I'm going to evaluate the radical aside. Okay? I'm going to use my calculator, and I'm going to do this aside. So let's see. So calculator. So I have 5 squared is 25, and I have to multiply. So negative 8 times negative 71, which is going to be a positive. So 8 times 71. So let's see what 25. 8 times 71 plus the 25. 593. I have no idea if this number is a perfect square, but I'm going to take the square root of it anyway. 593. And there you go. It's not. And that's perfectly fine. You're going to use this number, 2435, right? This is after I take the square root. So in here, what was it? The 593. And then we use this approximation. Let's just use 24.3, okay? Is it 24.3 or 23.4? 24.3 over 4. So here are our two answers, okay? Now, there's something important that happens here. When you have a geometric problem, you have to pay attention to the following. So first solution, negative 5 plus 24.3 over 4. Second solution, negative 5 minus 24.3 over 4. Okay. Remember, you're looking for the dimensions of the garden. In the second case, this is going to be negative 29 over zero point 0.3 over 4. Now, because this answer is negative and a dimension cannot be negative, I don't even need to calculate this. This is already out. Okay? It cannot be negative. A dimension cannot be negative. So this immediately is going to happen. So the only possible solution for width is the 24.3 minus 5 divided by 4. Let's say 4.8 approximately, okay? 4.8. Now, because we're not done yet, right? So remember the question, so you have to answer the question from the problem. Find the dimensions of the garden. We found one. We have the width. I have to find length now. So find length. But I had the original definition for length. All right, so this is 5 plus 9.6, which is approximately, what is it, 14.6? Okay. So in these geometric problems, okay, if we're finding length, for example, obviously the answer cannot be negative. If it's an application where we're solving for time, time cannot be negative. So the negative value will be removed. All right. The next application is somewhat very similar to this. It's a geometric problem involving the Pythagorean theorem. You may remember this from early in your math courses. So the Pythagorean theorem is a theorem that involves a right triangle. So if you see this symbol, that means the triangle has a 90-degree angle. When that happens, A and B are called the sides or legs. And C, the longer side, opposite to the 90 degree, is called the hypotenuse. When we have a right triangle, the Pythagorean theorem applies, and the Pythagorean theorem says the square of the hypotenuse is equal to the sum of the other two legs squared. Okay? So, and we can use this to solve a problem involving the quadratic formula. So let's take a look at this example. And this is our last one in here. So the hypotenuse of our, so they immediately tell you that they have a right triangle. So I can draw the right triangle. Okay. And then they say the hypotenuse of a right triangle is 5 feet long. So hypotenuse. This is your 90 degrees. Hypotenuse is always opposite to the 90-degree angle. One leg is 4 feet shorter than the other. I don't know what the legs are, so I'm going to call this X. And if this, the other one is the 4 feet shorter, obviously we're talking about that. Find the length of each leg. Now, once they say to the 100 foot, that's an indication that you're going to have to use a calculator because the answer is not going to be exact. It's going to be an approximation. So once I have the picture, I can use the Pythagorean theorem right here to solve the problem. So hypotenuse square, one leg square plus the other leg square. Okay, so this is 25 x squared. This I have to FOIL. X squared minus 4x plus 16. So x squared minus 8x plus 16. Okay, I can see at this point that I have a quadratic, which I need to make it equal to 0. So I'm going to do minus 25 on both sides. I'm going to get 0 here. I'm going to get 2x squared minus 8x. And I have to do 16, positive 16 minus 25. You can use a calculator if you want to. If you don't, if you can do this in your head, that's perfect. So this is 25 minus 16 with a negative sign. Okay. Now, at this point, you have to be able to recognize this is a quadratic equation. It may or may not be factorable, but I'm not going to factor here because we're trying to practice the quadratic form. right? So A, B, and C, I'm going to use the quadratic formula again. So minus B, no, notice that B is already negative. So it's minus a minus 8 plus or minus B squared minus 4 times A times C. Everything over 2A. Seems like A is always 2. In these problems, the A is going to be something small, so you guys don't have to work with too complicated numbers. So negative times a negative positive. Now, aside, I have to evaluate what's inside the radical. So let's use the calculator for that. So I have negative 8 squared is 64. And this is negative 8 times negative 9, right? So 72, 136. So 136 goes right here. Now, I don't know, maybe you don't know, we don't know if 136 is a perfect square or not, but that's okay. You have a calculator, you can do that. And there you go. It is not. Right? So for example, it's not like, let's say 144. 144, when you take the square root, we get 12. But 136 is this crazy number. And that's perfectly okay because this is an application problem. So I'm going to say that the answer is approximately 11.6. Okay. Now on the exam, if you want, you can use two decimals. It's perfect fine. And for the purposes of the video, I'm just using one decimal. Now, just as before, I'm going to have two answers, 8 plus 11.6 over 4 and 8 minus 11.6 over 4. Now, but the second one is going to be negative 3.6, right? I don't need to know what that is. This cannot be the answer because x is a length. So it cannot be a negative length. The only valid answer is the first one. So I have 19.6 over 4. And this is 4 point something. Let's find out what it is using one decimal approximation. 19.6 divided by 4. This is my 4.9. Okay, 4.9 approximately. So this is 4.9, that leg of the triangle. And the other leg is 4.9 minus 4, which is 0.9. All right, so this is your triangle. So these are the applications that you might see on an exam. All right, maybe a more mathematical problem or these two types of more geometric problems. And in all cases, we use the quadratic formula, but it may be that sometimes you may factor something. But in this particular video, we were just practicing using the quadratic formula.